First of all, we have two different kinds of mechanical energy, kinetic energy and potential energy. First of all, kinetic energy is the active energy of an object. That means when it's moving. There are different kinds of kinetic energy. They're vibrational, rotational, and translational. The formula we usually use to calculate any kind of kinetic energy is 1/2 mass velocity squares. So the potential energy. Potential energy is the energy that could transfer into kinetic energy at any given time. So it has energy, but we can't see it. We don't see it, but it will end up. The different kinds of potential is elastic, chemical, spring, and gravitational. The potential energy formula is for gravitational, it's mgh, and for spring we usually use 1/2 k, but it's the spring constant, x squares.
All objects in the universe have energy. For example, this 58-gram tennis ball I'm holding has potential energy. Now, since it's not moving, it has no kinetic energy. But when dropped from a great height,
the ball has a lot more potential energy. Up here, at a much greater height, the object still has a kinetic energy of 0, but when I drop it, some of that potential energy will be converted into kinetic energy. At the ground, when the height is 0, all of the energy will be kinetic and none will be potential.
before we can solve this problem for kinetic and potential energy, we first have to define our variables. The first variable, m, equals 0.058 kilograms. The next variable is the height where Omar is holding the ball, and that is 5.13 meters. Now, since there is no movement with the ball, the kinetic energy equals 0. That means that all the energy in the ball is potential energy. In order to find the potential energy of the ball, we have to use the equation for potential energy, which is potential energy equals mass times gravity times height. Filling in the variables, we have that the potential energy of the ball will equal 0.058 kilograms times the force of gravity, which, since we're on Earth, is constant at 9.8 meters per second squared, times the height, which is 5.13 meters. And that all multiplies out to equal 2.9 joules.
At this point, we are at a height of half of our maximum height, or 2.655 meters. At this point, our potential energy is halved because we are at half the height. So instead of 2.9 joules, we are at 1.45 joules for our potential energy. Due to conservation of energy, our kinetic energy is going to have to be the exact same, since in total, they must add up to 2.9 joules.
So now, in order to find the kinetic energy of the ball at the lowest point in its descent, we need to first define our variables. The mass is still the same that it was at the very top, which is 0.058 kilograms. The height, however, has changed. The height is now 0 meters. In order to find this energy, it's all going to be kinetic energy, so we can use the law of conservation of energy, which states that the initial potential energy plus the initial kinetic energy is equal to the final potential energy plus the final kinetic energy. Now, the first parts of these, we know from the previous problems that the initial kinetic energy was equal to 0, and that the initial potential energy was equal to 2.9 joules. Now, because the height of this problem at this point is 0, we know that the final potential energy is also equal to 0, because when you multiply the mass times the gravity times the height, that will equal 0 meters when the height is 0. So solving for this, solving the equation, we can find that the kinetic energy at the final point in its descent will simply be equal to the potential energy at the highest point of the ball's trajectory, which is 2.9 joules.